We're looking at a neural netverse, and we're trying to understand what happens when we try to send currents through these different fields and try to close them all. It turns out that as we go through each layer, start with layer 1 here, this is a 1 by 1 layer. So we just have basically a number, and it's going to have, a little current that flows through these fields. We have spin 2 field, 2 spin 1 fields, and a spin 0 field. And we can ask yourself, okay, well, what are all the different ways that these things can sort of create loops, as in Kirchhoff loops? And if we try to calculate that, remember the Kirchhoff loop is supposed to equal to 0 if you go around the loop. And here's the different components that we have. We got, the spin 1, 3 component, we have the spin 2 component, or sorry, SU2, SU3, and U1 component. These components all sort of need to loop together, right? And it's hard to sort of draw this out because this is a very spirally type of situation. The idea is we're trying to combine everything together in different ways. So at the first level, we're going to just have a gauge activation, right? The U1 just sends out this gauge activation, and we can see kind of what it looks like. These are the basically the triangle anomalies with the Feynman diagrams. We can see how we have the recurrents that meet up in this little loop here, right? And so the equation that governs this is this idea that you've got gauge field curvature, and so this is the curvature across the gauge fields here, and then this is the current that comes out of it. So you got, you know, basically three currents that come in here. And this starts to wrench its way downward. As you can see, we're always getting this single current that comes through here with, we have to connect. We have to connect a double current, we have to connect a triple current, and a quadruple current. All of those have to connect together, and you can see that most of the time we just end up with a single current popping out here. So this is one type of anomaly, and it appears at the first layer, and it sort of pops its way down through all the layers because, well, this is a neural network. And the next layer here, we have the SU2. So we've got sort of this double helix coming through. And this is a 2 by 2. And we have to send that through. The current has to go through all these different channels. Okay, and so you can see once we start combining these two, well, the interesting thing is that in the second layer, we don't have the same type of anomaly. It's a completely different anomaly. In fact, it's a global anomaly. And so now the mod 2 global anomaly starts to apply to everything. So in the first layer, we have the gauge activation that you can see sort of rides down through all the layers, 1, 2, 3, 4. In the second layer, we've got a global anomaly that applies to all the layers. So each step is trying to sort of apply anomaly activations, these are nonlinear activations for each layer that are sort of going to apply for the rest of the layers. So we have our first two layers, mod 2. On the third layer, we have this triple helix. So it's SU3, it's a 3 by 3, and it's going to come through and it's going to shoot through the different channels. Well, strangely enough, if you just do a regular old anomaly calculation here, we don't really get any new restrictions. The third tier just doesn't really have anything interesting about it. It still has to calculate the triple current here. You get two curvatures coming in with one current coming out. It's fine. So you kind of have this situation going on. The third layer is not very interesting. Once we get to the fourth layer, we get this quadruple type thing happening, a 4 by 4. And we ask ourselves, okay, how do these gravitational waves flow through the different channels? Okay, this is one way to look at it. There's different ways to look at this stuff. The idea is that we're going to be sending these uh, 1, 2, 3, 4 different types of currents through these four channels. And I like to think of it as that these ones give you the currents that can come through, and this one right here, this is just a spin 0. Well, it's just going to have a number, so that's sort of your hypercharge. Um, but in this last layer, in step 4, we actually have two activations happening. The gauge gravity activation, and as you can see, it's kind of like this, where we have to take the gravity, this is 4 by 4s, and then it becomes a gauge. There's a 1 by 1 out there. The gauge is always just 1, so that's again this thing. It's a similar type of thing, but instead of taking the gauge field curvature, we're just taking regular curvature here, gravitational curvature. This is the R's. So there it is. This is going to be our gauge gravity activation. And Essentially, this is the tangent bundle curvature into the gauge field. So like there's curvature that's like coming from space-time or something, and it's curving into the gauge field. It's hard to really visualize this stuff. And then finally, in this fourth layer, we also have a linear activation or a gravitational, pure gravitational activation. And that is basically that two gravitational wave curvatures here, two curvatures, can intersect with this current. The current is actually the coaxial current that goes around the loop right here. So actually, this is the current, the one that's literally tangent or parallel to this loop in here. That's the current that we're sort of analyzing. But this is sort of like a visual representation of this. So it's hard to sort of represent this with visuals. But the idea here is that we've got two curvatures coming in and a different type of current coming out. It's not the same current as these ones. It's a different type of current. And so these are the activations that can happen at the different layers. Layer 1, we got the gauge activation. Layer 2, we have a global activation. Layer 3, we don't really have any activations. In layer 4, we've got two types of activations that both involve gravity. And, if we're thinking about looking for new anomalies, we probably won't find any. But there are models that are trying to get massive neutrinos where we could sort of send some kind of a 1-1 with zero charge through, and this will represent a massive neutrino. So this could be, and it could also be another way that we can toss in dark matter if we have something that has neutral charge, because all these things basically cancel the charges and they create charges for the particles. So anything that has no charge might be able to pass through the system without being activated in these nonlinear activations. So you could put stuff through this that doesn't get activated. And that's what they think, massive neutrinos or dark matter could be. These different things that pass through the system without being activated. All right, so hopefully this is kind of interesting, looking at the neural netverse in the idea of a Kirchhoff loop anomaly. Oh yeah, and let's not forget that usually when we're looking at um, quantum or currents, or sorry, circuits, if you look at like dissipation, thermal dissipation, um, I remember there was an equation that links curvature to thermal energy, so it's quite probable, in fact, that all these anomalies just come from curvature that would be causing little mismatches in the wiring that kind of causes this loop to not close to become zero. And if there's any kind of curvature, it would make the loop not be zero, and therefore you need a charge to fix that. And so therefore we have the reasons why the anomalies happen is because there's curvature in the neural netverse. These curvatures are causing the circuit components to not line up properly, and they require charges to close them. This is some crazy ideas, but hopefully it makes a lot more sense. Thank you all.